Welcome back, college algebra students. I got a couple of more videos and then you can count this midterm review done. I hope you've been working along with me, reversing, fast forwarding, pausing where necessary to make sure you understand these concepts. In this section, starting with problem number 32, we're going to be dealing with operations on functions. Not a hard section. The most difficult thing is just understanding what the notation means. So on problem 32, we're given two functions, f and g, and we are asked to add these two functions. The first step in applying operations to functions is simply to break it down in terms of the two original functions. So f plus g of x is a shortcut notation for f of x plus g of x. Then I'm going to replace each of those function names with their function rules. So if I start with f of x and I observe what is the rule for f of x, it is 5 minus 3x. So I'm going to completely replace the function name with the function rule. I'm going to do the same thing for g of x. I'm going to replace the function g of x with its rule, completely replacing the name there, calling it x squared minus 16. Once you've done all your substitution, your goal is to simplify, making sure to put it in descending order. So I'm going to start with the highest powered x, that would be x squared. The next highest power would be the minus 3x term. Combining 5 minus 16, we end up with minus 11. So our answer here, again, we're not solving for anything, we're just combining the functions and simplifying. Now, domain for any polynomial function will be negative infinity to infinity. If your function does not have a fraction or a radical, your domain will likely be negative infinity to infinity. On problem 33, we're using the same two functions, but in this case, we are subtracting the functions. So we want to evaluate f of x minus g of x. So I'm going to replace f of x with its function rule, as we did in the previous problem, 5 minus 3x. And in this case, I'm going to subtract g of x. Now be careful here, because if I just plug in the function rule for g of x, it's not going to give me the right answer. I have to make sure and subtract all of g of x, which means I need an intentional set of parentheses there. This is going to indicate that on the next step, I need to distribute the negative. And in this manner, we will have subtracted both terms of g of x from f of x. Distributing our negative, we end up with this step. And combining like terms, putting the whole thing in descending order, we end up with x squared minus 3x plus 21. Whoops, negative x squared minus 3x plus 21. Again, it's a polynomial function. If you were to graph it on your calculator, you'd see a parabola. So the leftmost x value on the parabola, negative infinity, and the rightmost x value, positive infinity. On problem 34, in this case, the operation is multiplication, but we're using the same two functions. Now, you may want to keep those handy. I'm going to scroll down here so I can have the white space. So in this case, we're going to take the function f of x and multiply it by the function g of x. We know that f of x is 5 minus 3x. Since we're going to be multiplying binomials here, be really careful, make sure you include parentheses. Same thing for g of x. Remember, g of x was x squared minus 16, and the presence of those parentheses clue my brain that I should FOIL this stuff out. So foiling gives us the product of the first two terms, 5x squared. Product of our outside terms, we have 5 times negative 16. It's going to give us negative 80. Product of our inside terms, negative 3x cubed. And last, we end up with 48x. Combining like terms and rewriting this in descending order, we have negative 3x cubed plus x squared term comes next, 5x squared plus 48x minus 80. Okay, so that is sufficient work for that problem. We do want to go ahead and report our answer in the answer blank. and then state the domain. How'd we do on number 34? I'm going to check our answer. Make sure, yes, we are in good shape. Domain here, negative infinity to infinity, because it's a polynomial. Now 35 looks complicated, but you're going to find out this is probably the easiest one to assimilate. We're dividing the functions, so we need to do f of x divided by g of x. So all I have to do here is stack them up. F of x was the 5 minus 3x. G of x was x squared minus 16. This is not going to reduce in any way, so we are good to go. Again, it looks complicated, but it's probably the easiest one. So there's the quotient, f divided by g. Now notice, in this function, it is a fraction. Remember, the domain will be negative infinity to infinity as long as you don't have a fraction or a radical. So what do we do with a fraction? Well, we want to make sure that we never divide by 0. So I have to make sure that this denominator, x squared minus 16, is never equal to 0. If it's equal to 0, I have an undefined function. So what values of x would cause this to be 0? Well, I'm just going to solve this little quadratic equation for x. Take the square root of both sides. Okay, so on that step, what happened? Took the square root of both sides. So x cannot equal positive or negative 4. If x is equal to positive or negative 4, the value of the denominator is 0, and I have an undefined function. So if I imagine a number line, I want to use everything on that number line except negative 4 and 4. It's like I'm plucking those points off of the number line. And the domain will be everything else. So I'm going to describe that domain in interval notation from left to right. So the leftmost value there is negative infinity. And then we're going to move up just to the left of negative 4, but we're not going to include negative 4, so I have to use a parenthesis. If I used a bracket there, that would indicate I'm including negative 4. And we know that's what makes the denominator 0. So then we're going to jump over negative 4 and start just to the right of negative 4 and go to 4. So that describes this middle region right here, negative 4 to 4. By the way, the U means union. I'm simply uniting these three intervals to describe the domain. The rightmost interval here goes from 4 to infinity. So evaluating the quotient's pretty easy. You just stack up the functions, but you have to work a little harder on that domain. Again, we set the denominator equal to 0 to find out what values of x made it 0, and then excluded those from the domain, and wrote that in interval notation. Problem 36 brings us to a new type of operation. We have added, subtracted, multiplied, divided. Now we're going to evaluate a composition. That little circle is composition. We read this f composed with g of x and g composed with f of x. So to evaluate f composed with g of x, this is really a function evaluated at another function. So we're going to take our leftmost function and write it first. And its argument is going to be the function g of x. So f composed with g of x means f of g of x. We're going to work our way inside out. So starting in our innermost set of parentheses, f is going to be patient and wait its turn here. We're going to replace g of x with its function rule, x plus 2. So this says go to the function f, there's f, and replace the argument, right? This x has now become x plus 2. So I'm going to take x plus 2 and put it in this red box. This is going to give me x plus 2 quantity squared, and then minus 4. Next step is to simplify. So we want to multiply x plus 2 times x plus 2 using FOIL. That's going to give us x squared. Now, quick shortcut here, the outside and inside terms are both 2x. When we combine those, we get 4x. Last terms there are 4, and we still have this minus 4 on the outside. Simplifying, we end up with the composition x squared plus 4x. Now don't jump to conclusions. G composed with F is not necessarily going to be the same thing. We're going to have to evaluate this one in a different order. This time, G is going to be on the outside, F is going to be on the inside. So we begin by replacing f of x with its function rule, and G is going to wait its turn. So f of x gets replaced with x squared minus 4. Now this says go to the function g, so I'm going to go to g. I'm going to replace the argument with x squared minus 4. So that x squared minus 4 is going to land right there where the variable is. So we end up with x squared minus 4, that's what we put in the box, and plus 2. Simplifying, we end up with x squared minus 2. Piece of cake. Now that's going to take a little practice, but the more you practice, the easier it will become. Problem number 37, we're still working with compositions, but we're also going to acknowledge the domain of these functions. So in this case, we're going to find f composed with g of x. Do you feel like you're in a fog? I know that's what you were thinking. F composed with g means f is on the outside, g is on the inside. Starting on the inside with g, I'm going to pick up g's function rule, which is this square root of x. So that's going to come right here and replace that function. We have f of square root of x. Now, this line says, now go to the function f. So I'm going to go to f. I'm going to replace its argument with the new argument, square root of x. So the square root of x is going to go right there where the variable is. We end up with 3 times the square root of x plus 6. Nothing to simplify here, so we've successfully composed those functions. As far as finding the domain of this function, remember, if you have a fraction, you make sure your denominator is never 0. If you have a radical, you have to make sure that your radicand is either positive or 0. Because if you get a negative value for this radicand, that's going to give us an imaginary number. So the trick on finding the domain of a radical function is to take the radicand out and set it greater than or equal to 0, and then solve any equation that may result. In this case, we're done. Our domain is stated x greater than or equal to 0. We simply have to translate that to interval notation. So we're going to go all numbers greater than 0, starting and including 0 up to infinity. All right, that was so much fun. Let's do it backwards. Let's work g composed with f of x. So g is on the outside, f is on the inside. Let me clean up my workspace here so I can clearly see those functions. We're going to start with f of x on the inside. So I'm going to go find the function f of x. There it is right there. And I'm going to replace the name f of x with the rule 3x plus 6. So we have g of 3x plus 6. That's step 1. Step 2, I just have to interpret this notation. If I could hear it talking to me, it would say, hey, go find the function g. There's my function g. Replace the argument with 3x plus 6. So I'm going to find the argument. That's the variable. I'm going to put a box around it, so this 3x plus 6 is going to land in that box. So we end up with the square root of 3x plus 6. And that's that. We have successfully composed the functions. Notice that radical extends out over that plus 6. To determine the domain of this function, remember your shortcut is to take the radicand out by itself and set it greater than or equal to 0. In this case, we have to do a little bit of work to find the domain. Not a big deal. We can solve this linear inequality by isolating x. And in this case, we find x is greater than or equal to negative 2. So we're going to go from negative 2 to infinity. Okay? So composition is easy once you practice, you figure out where everything's going to go. Start on the inside and work your way outside. Then it'll work out the same way every time. Okay, moving on to problem 38. Now, please don't panic. I know when you see this word problem, your heart sinks and you panic. But let me help you with this. We are simply going to be finding a composition on this function, on this problem. 38 says, due to a lightning strike, a forest fire begins to burn and is spreading outward in a circle. So you've got a lightning strike that hits, your fire begins to spread, and as time goes on, it spreads out further and further and further. Okay? Here's my rain cloud so you can get a visual. So the radius of this circle is expanding. Okay? The radius is modeled by the function r of t equals 2t. So the radius is a function of time. As time increases, the radius increases. Notice the time is measured in minutes and the radius is measured in meters. Now I want to calculate the area of the region burned. That's given by the function a of r equals pi r squared. Hey, you should recognize that as the formula for the area of a circle. Write a function for the area burned by fire as a function of time. Now don't panic, just follow the math. It says find A composed with R of T. Okay, don't panic. Do the same thing you've been doing on our previous composition problems. That is, A is on the outside, R of T is on the inside. I'm going to start with R of T. I'm going to replace R of T with its function rule, and we're going to end up with A of 2T. Next, I'm going to go to the function called A. There it is right there. I'm going to find the argument. In this case, it's called R. And I'm going to plug the 2t into that box. So I have pi times 2t squared. Okay? Now let's simplify. Being careful to distribute that exponent to both factors in that product, we have 2 squared and t squared. 2 squared is 4. Let's write that 4 left of pi. And now we have a function that describes the area of the region burned in terms of time. We're basically skipping the middleman called radius. So we have 4 pi t squared. Finally, it says determine the area burned in 60 minutes. So we want to calculate A of R, which we just found. That's the 4 pi t squared of 60. So I'm simply plugging 60 in for t. Okay, and let's approximate this. 4 pi times 60 squared. I'm going to need my calculator for this one. Not sure I can do that one in my head. So we have 4 times pi. Pi is over here above your caret key. So to access it, we have to press the second key and the pi key. Times 60 squared. And we'll round it off to the nearest whole, 45,239 square meters. So 45,239. Remember, area or radius was measured in meters, so area is in square meters. Again, when you see the word problem, don't panic. Focus on the math. What is it asking me for? It's simply asking me to compose those functions. If I follow the process, I'll be able to work that word problem. No problem. All right. Next video, we will finish out the review. Thanks for listening.